Hello, dear my friends. Welcome to the question session for hydrocarbons 1 and 2. I'm going to solve and explain questions for you. Let's start with the question 1. What are the products of complete combustion reaction of alkanes? This means an alkane react with oxygen. And the products are a water molecule and the carbon dioxide in a complete combustion. What happens if there is an incomplete combustion? The products will be water and carbon monoxide, a highly toxic gas for body. The carbon dioxide, as you know, is delivered with hemoglobin, and it happens in a every day at every moment of our life. But this is called carbaminohemoglobin. Carbaminohemoglobin. But the carbon monoxide, when attached to the hemoglobin, which is called carboxyhemoglobin, carboxyhemoglobin, it can cause harmful effects. And if a mammalian suffered from high carbon monoxide inhalation, can be life-threatening. So we should be very careful. In here, the methane and carbon dioxide, these are not answers. And here we have the ethanol and alcohol and carbon dioxide. These are not answers. This is the answer. Let's continue to other question. Which of the following statements about alkanes is not correct? So when you are reading a question, please be very careful what is asking to you. And there are questions asking to find the correct or incorrect statements. And here, this is about alkanes. The general formula is n number carbon atom to n plus 2 number of hydrogen atoms. This is a general formula of alkanes. But which type of alkanes? Aliphatic alkanes. Aliphatic alkanes, which means a chain structure of alkanes. But also don't forget, if we have a cycloalkane, which means an alkane having a ring structure, its general formula will be n number carbon atom and 2n number of hydrogen. So the general formula will be n number carbon atom and 2n number of hydrogen, as in the alkenes, They do not give addition reaction with hydrogen for the alkanes. Yes, this is also true, but don't forget they can give an addition reaction with halogens. It can happen, especially in a high level of temperatures. They are soluble in water. This is incorrect because they are soluble in organic solvents such as carbon, such as, let me to raise it for you to better writing. Okay, such as carbon tetrachloride or chloroform. The combustion products are carbon dioxide and water. This is also true. And alkanes are inert molecules. They do not want to undergo many different kind of reactions, but they can go combustion reaction. Question 3. A common type of question that you will have also in the exams. So you have a molecule here, and I want you to put the UPAC name of the alkane compound. The UPAC name means its systematic name. It's systematic naming according to the UPAC rules, the International Union of Pure and Applied Chemistry. For some elements, also there are common names. We can say a kind of private names. So you should be very careful which type of naming is asking to you, UPAC or common name. And here is this is the UPAC naming. And we have a formula to put a UPAC name of organic molecule, a simple formula, prefix plus parent chain name, parent chain plus suffix. And suffix represents the superior functional group in an organic molecule. And look at that molecule, look at here. As you see, there are only carbon atoms and hydrogen atoms, which makes the molecule a hydrocarbon. And there are four types of hydrocarbons: alkanes, alkenes, alkynes, and aromatic ones. And as you see, there is no any carbon-carbon double bond or triple bond or any cyclostructure in the given molecule. So it's an alkane. So the suffix will be "ane." The parent chain represents the longest carbon chain carrying our functional group. And here, this is a very simple molecule. There is only, look at here, 4 carbon chain. And to name the parent chain, we have to use UPAC multipliers. And the multiplier for the number 4 is but. So which this makes our molecule butane. And as you see, there is no any substituent or any other group that we have to name them as prefixes. So prefixes are the substituents. Is there any substituent? If yes, what are they? How many? And where are they? Or the locants. Also, we can put locant, which means the location of substituent. The location means at which carbon atom in the parent chain include the substituent. And we will have examples. Yes, this is butane. To be an ethane, there must be 2 carbon chain. For propane, 3. Which of the following is a skeletal isomer of 2-methyl propane? And here is a carbon chain, propane. The prop means 3. Let's draw. We have it 1 carbon, second carbon, and the third carbon, the zigzag lines. And the name tells us there is a prefix here, the suffix "ane." So there is only the single bonds. And there is a prefix at the position 2 in the parent chain. There is a methyl group. There's a methyl group here. So this is the propane. And in total, as you see, there are 4 carbon atoms. And 4 carbon atoms plus 4 times 2, 8 plus 2, 10. So let's analyze the given options. The propane, it's an incorrect option because only 3. And as you see, all options or the given molecules in the options don't carry any substituents, only a parent chain. So it will be very easy to us. Just remember which one has the 4 multiplier. And hexane 6, pentane 5, and butane 4. So this is the answer, my friends. So the butane and the 2-methyl propane are skeletal isomers because they have different carbon structure, different chain, different structure of carbon chain. Yes, finally I did the sentence. Yes. And the question 5, there is a given group to you and asking to name it. And as you see, there is an alkyl group. So alkyl groups are the substituents, which We obtain them by removing one hydrogen from the end of a parent chain. For example, if there is a propane, this is propane, there is a CH3, for example, here, CH3, and actually here there is a CH2. So if I remove a carbon or hydrogen, sorry, here, which makes CH2, this means I will empty a carbon single bond in a given molecule and make it available to attach to a carbon chain. And we call them alkyl group. A similar naming also done in alkenes and alkynes, which we call alkenyl and alkanyl for the alkene and alkynes. Yes, sometimes it's not easy to spell them. Yes, and as you see, to name an alkyl group, the rule is put the name of the alkane, and drop ane, and instead put y and l. So if it is pentane, pentenyl, hexane, hexyl. Look at the question. There are 3 carbon atoms. Assume it's an alkane. It would be propane. So the rule tells us if it's an alkyne, drop ane and put Y and L, which makes it propyl. It's C. The methyl is CH3. Butyl is 1, 2, 3, 4 CH2. And for the ethyl, CH3, CH2. This is ethyl. The given is propyl. Yes, we have a given organic molecule here. And again, the systematic name is asking to you, which this means we have to follow the UPAC naming rules or the UPAC nomenclature rules. Yes. And remember the formula, the prefix plus parent chain plus suffix. And it's easy to reveal that. Look at the formula given to you. There is only carbon-carbon single bonds. So the suffix is "-ane". Let's check the options if there is any having different suffix, which help us to eliminate some, but there is no different suffix. All are "-ane". Yes, the second thing is to find the parent chain. And as you see, there are substituents. So at that level, my friends, be very careful, because the given formula can can create a confusion. Don't assume or don't think that always the given chain in a horizontal line is the parent chain. The rule tells us find the longest carbon chain, longest continuous carbon chain. So there are different options. So this may be the longest carbon chain, or this, or maybe this one, and as well as maybe this one. So you should evaluate all options. This is so important to find the longest, and be careful, continuous carbon chain. Let me erase, yes. Let's discuss all of them and look at here. So starting from here, 1, 2, 3, 4, 5, 6, 5, 6, 7, 5, 6, if this way also 7. And as you see, this methyl and this methyl group attached to the same carbon, so there is no difference here. Actually, they are same. Like either this or this, they are same, no difference. So, mm, I'm trying to find the eraser. Okay. Assume this is the longest chain. We accept this one. Yes, how many carbon atoms? I count 7 carbon atoms. So what is the UPAC multiplier of 7? The UPAC multiplier of 7 carbon is hepta. And we have the suffix which makes it heptane. So this means option B is eliminated. But other ones are heptane, as you see, heptane. So it's time to name the substituents. So if this is the parent chain, and as you see, there are 3 substituents in the parent chain, which 2 are methyl. They are alkyl groups, by the way, methyl, and 1 is ethyl. So let's analyze, let's check the options if there is any different naming. Ethyl, methyl, ethyl, methyl, ethyl, methyl. So at this point, we cannot eliminate any of them. But don't forget, we eliminate the option B. Yes, so the prefixes answer these questions. The first question is there any substituent? Yes. So if it is yes, continue. What are they? Methyl. And how many? There are 2 methyls, which makes dimethyl. Dimethyl. And only 1 ethyl. So let's look at the options. And as you see, all options include dimethyl and ethyl options. Still, we cannot eliminate any of them. And the third question is, where are they? Or the locants. Locants means at which carbon atom they attach to the parent chain. So here is the rule, my friends. In the naming of organic molecule, we have to give the possible lowest number to the carbon atom in the parent chain having the first substituent. So in the parent chain, we have 2 options. You can start from the left side or right side. But before, yes. Let me to erase. Okay, yes. If we start from the right or this carbon to number the carbon atoms 1, 2. And as you see, the first substituent is at the position 2. If we start from the left side, 1, 2, 3, 4. So this means the first substituent is at the fourth carbon atom. So which one is correct? The rule says us this is the correct one because the rules wants us to detect the first carbon atom in the parent chain having the first constituent or substituent. So this is the true. Let's continue. Let's continue to erase this one. Okay. Yes, as you see at the second carbon, third carbon, and fourth carbon, we have the substituent. So the ethyl group is at the fourth. And there is a 2, 3 dimethyl. Dimethyl heptane. So as you see in option C, in option A, include the both 2, 3, and 4 ethyl. So we can eliminate the option D because this numbering is done from the left side, from the incorrect side. So what is the difference between option A and C? And here is you see ethyl group is put before methyl, and in option C, methyl is put before the ethyl. So which one is correct? So here we need an additional rule. The UPAC systematic naming rules tells us order the substituents according to their alphabetic order, which I mean according to the alphabetic order of the initial letter. And here the E comes before M in the alphabet. Thus, we have to write the ethyl group initially, then the methyl group. But don't confuse about the D. D here is a prefix telling us there are two methyl groups. It's not the name of the substituent. So this is the correct option. 4-ethyl, 2,3-dimethyl heptane. This is the name of our organic molecule. The boiling point of alkanes increases as the number of carbon atom increases. This means the longer chain of an alkane means increased boiling points. And inversely, the boiling point of alkanes decreases as the number of carbon atom decreases. For example, what about the boiling point of methane? It's about minus 161 degrees Celsius. And for the propane, minus 42 degrees Celsius, and the butane minus 0.5 degrees Celsius. And these are gas at room temperatures, also in nature. And there are the components of natural gas. But what about the pentane? There is a 5 carbon atom. It's plus 36 degrees Celsius, and it is liquid. And as you see, just increase the carbon atom one number from 1 to 3 to carbon atom, sorry, the boiling point change dramatically. So the answer is A. Another naming here, which is the epoch name of the given compound. And as you see now, it's very easy that we have the "ane" suffix and all "ane." And as you see, all having heptane. So this means there is an heptane, or maybe an incorrect question. Rest of the longest chain. So start from here. 1, 2, 3, 4, 5, 6, 7. Here 7, 6, 5, 6. So this is the longest chain. This is the pattern. Longest chain. So the remaining is to name the prefixes. And as you see, there are prefixes. There are substituents, locate them, and give the names. Locate and also say how many, if they are the identicals. Yes, I guess you easily understand the numbering that I did are incorrect for now, so let's erase it. Okay. It's because the rule says us look, number the carbon atoms in the parent chain according to the one having the first substituent. And now it's very easy. This is the first carbon in the chain, second, third, and fourth. That's okay for now because there is no any substituent of the fourth carbon atom. And as you see at the 2,3, we have the dimethyl, 2,3 dimethyl. This may be correct. And also this may be correct. But be careful. Here in the option A, as you see, 2,3 is written, but what is missing? There is no D. Don't forget, if there are two or more identical substituents, we have to put the prefix saying how many. So D methyl, so which now we eliminate this and also eliminate this. There is no D suffix, but here we have the D suffix, and also here we have the D suffix. And at the fourth carbon atom, as you see, there are two identical groups. So we have 4,4 D Don't forget the ethyl group. And this option have included the ethyl at 4,4, but the C is the correct. And I hear your voice saying the answer is C because E comes before M. This is the correct naming. Another naming, UPAC name of the given compound. And as you see in this given molecule, it's not clear of the carbon and hydrogens, but we know them. We know them because, as you remember from the previous lectures, it's not necessary in this exact formula to write the carbon and hydrogen. We can omit them. So we know at each point there is a carbon, and here we have 3 hydrogen. Carbon and 3 hydrogen. If there is a heteroatom or any different pattern, we have to write. Assume, where is the eraser? Yes. Okay, if at the end of chain, if there is a hydrogen, only hydrogen, I have to write it. If you don't see any hydrogen symbol written, this means there is a carbon, there's a carbon and carbon having 3 hydrogen. And don't forget, carbon always form 4 single bonds or 2 single, 1 double, or 2 double, or 1 triple, 1 single bond. In general, always form 4 bondings. And here we have a cyclic structure. So we remember the formula: prefix plus parent chain plus suffix. If we have a cyclochain, or a cyclic structure, we need to modify the formula. We have to put a prefix in front of the parent chain, which is cyclo. This represents the parent chain carrying cyclic structure. Or a cyclic structure can be an alkyl group. And for the alkyl group, drop the N and put Y and L. So if it is, for example, cyclohexane, it will be cyclohexyl. Let's do the example. So we have a cyclic structure and a chain structure here. So the suffix is ane. That's easy for now. There is no any double bond, no heteroatom, or a benzene ring. It's the ane. So there are 2 possibilities for the parent chain. The cyclic structure can be the parent chain, or the given ring structure can be the parent chain. To identify which one is the parent chain, we have to count the number of carbon atoms, as we did before. And it's very easy, my friends. It's very easy. As you see, in the cyclic structure, there are 1, 2, 3, 4 carbon atoms, but in the given ring, given aliphatic chain structure, we have a 1, 2, 3, 4, 5, 6, 7. So the chain is the parent chain, 7, heptane. So eliminate the butane, butane, butane. This is the correct option. We don't need any more to reveal the rest of the parts of the molecule, but we will do it. So we have a 7 heptane containing a cyclo. Look at the number of carbon atoms: 4 butane, cyclobutane, but it's an alkyl, cyclobutyl. So it's a cyclobutyl substituent at the 1, 2, and 3. We have to number starting from the right. If we start from the left side, it will be 1, 2, 3, 4, 5. So this is the true. 1, 2, 3, which makes 3 cyclobutyl heptane. This is the correct option. Be careful, my friends, because there is a common error done by many of us, actually, many of the students. When we see a cyclic structure, don't assume or don't decide it is the parent chain. Always count, always count the number of carbon atoms, or always evaluate all possibilities, because the rule tells us the longest continuous carbon chain is the parent chain. Continue. Another name, which is the name of the given compound according to the UPAC nomenclature rules. And here, as you suddenly realize, there is a carbon carbon double bond, which makes the suffix "-ine". And let's look at the options. All have "-ine" suffix, so we cannot eliminate any of them. So, if till now, for the alkanes, they are easy. And as a common approach in a naming of an organic molecule, you can always assume it's an alkane. So give the alkane name, for example, and then derive it to the real naming, or to the functional group naming, which presents in the given organic molecule. So give the alkane name, drop "-ane", and put the suffix for the functional groups, which is "-ine", for example, here. So this is the longest carbon chain. I assume it's now very easy for you. 1, 2, 3, 4, 5, 6, 7. So there is a 7, which is heptane in real. But if we assume it's an alkane, but due to double bond, it's an alkene. So draw the "-ane", and which make is heptene. Heptene. So this is eliminated. Hexene. We have three options. This is heptene, my friend. So now we have an additional thing. If there is a real functional group, the name must also include the position of functional group, which here it is the same approach as we did for the substituents. So to name or the position to give the locant of the functional group, it must be at the first carbon atom in the parent chain. And we have two possibilities, count from the left and right, but it easily the correct side is the right side. So 1, 2, and 3. And also there is another important rule. As you see, there is an alkyl group here and also alkyl group here. And if we omit the double bond, or if we omit it's an alkene, or if we accept it's an alkane, as you see, we can also start from the left side. But here, the functional group is superior than the substituent group. And so, put a question mark or exclamation mark. If there is a real functional groups, always focus on the functional group. The substituents will come after the position of functional group. So, or in other words, if there is a real functional groups such as alkene, the double bond, triple bond, or also in the following topics, alcoholic group maybe, or sulfitryl group, we have to focus on the position of functional group. Or in numbering the carbon chain, we have to locate the first carbon having the functional group, and actually having the superior functional group. Because if there are two different type of functional groups, then we need to remember their order of priority, and we will focus on the superior one to give it to give the possible lowest carbon number of the parent chain having that functional group. This is so important. And here it is 3, which makes it a 3-heptene. So the 3 number here refers the position of double. And if there are substituents just in front of the position of double bond, we have to put them. And as you see, there are 2 methyl groups at the position 2 and 6. So it will be, my dear friends, 2, 6, the methyl 3 heptane. Yes, this one. 2, 6, the methyl. 1, 2, 3, 3 heptane. This is the correct answer. So name the given compound according to the UPAC nomenclature rules. And as you see, there is a 4-carbon cyclobutane actually, and the substituent here methyl, which makes the ring structure the parent chain. So it is cyclobutane? No. Look at here, there's double bond. It will be cyclobutene. So this can be the option, this can be the answer, this can be the answer. But here, no, because in this naming, the methane is accepted as a parent chain, but it's not correct because the parent chain is cyclobutene. And as you see, there is a methyl group, so it will be methyl cyclobutene. Eliminate the option D. And if there is only one substituent here, and also the double bond here, in the ring structure numbering, we have to give it a number either clockwise or counterclockwise. So if there is only one substituent or 2 substituent, also there may be 2 substituent, so we have to give the possible lowest number to the substituent in the ring chain according to the position of double bond. And here the substituent is attached to the one end of the double bond. And if there is no any other, it will be the 1. So the answer is 1-methyl cyclobutene. A common name of the organic compound, and here you see the benzene and having an hydroxy. This is actually hydroxybenzene, but instead of hydroxybenzene, we have a common name. It is the phenol. And let's give an example for you. For example, vitamin E. Vitamin E carries that phenol group. And also some hormones can have this kind of functional group. It is very important group, and it is a potent antioxidant. So this group gives the molecules to be a potent antioxidants, which they prevent the formation of free radicals, or they scavenge the free radicals. They are good molecules for us in the body. It is obtained, blah, 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 by the addition reaction of an alkene with hydrogen. If we have an alkene, for example, a carbon-carbon double bond here, if you put 2 hydrogen, which means we break the bond, and add 2 more hydrogen. And as you see, the alkene is converted to an alkane. If we add water molecule, which means one will be an OH, water molecule, it will be an alcohol. To get an aldehyde, we need to add more, or to get an aldehyde, the molecule must undergo oxidation reactions. And oxidation, firstly, alkene is converted to alcohol, then aldehyde. It is obtained blah 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 by hydration of propene, and more specific. One of the hydration of an alkenes gives alcohols. And here only one option having alcohol, propanol. This is B. And assume we have another alcohol such as butanol. Again, the result will be propanol because we have the alkene propene. What is the UPAC name of the given compound according to UPAC nomenclature rules? And as you see here, we have a triple bond. So which makes this a suffix IN. So all, let's analyze INE, INE, INE. So we cannot eliminate any of them. And then we have to reveal, we have to find the longest continuous carbon chain. And it's very easy, as you see here. This one. This is the longest carbon chain having 1, 2, 3, 4, 5, 6, 7, 8. So it is octine. It is octine. So we can eliminate this one and this one. The second one is to put the position, the locant of the triple bond. And if we start from the left, it will be 1, 2, 3. Starting from the right, 1, 2, 3, 4, 5. So this is the true numbering pattern. 1, 2, 3, 4, 5, 6, 7, 8. And we have a 3-octine only at the option 8. Now, this is the answer, but also we have to continue. As you see at the 6 carbon atom, there are 2 identical groups, methyl, which makes the 6,6 the methyl 3-octane. And so if there is a D suffix saying there are 2 methyl, we have to put the both numbers. It doesn't matter if they are at the same carbon, same carbon atom of a parent chain. Still, we have to write 6, 6. If you write only 6 and the dimethyl, this is incorrect because this opens a question. Which one is correct, or is it incorrect, or which? Sorry. In this aspect, for example, as here, as you are seeing the molecule, but what happens if I only write the name, for example, 4, 5, methyl, blah, 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 and ask you to draw the molecule? You cannot draw, or you should ask to me a question about there is a missing part in the compound or an incorrect naming. Because I write here, I ask you to draw 4, 5 methyl. So if the 4, 5 is true, that's saying there are 2 methyl, so the name must include D. Or maybe actually there are no 2 methyl groups, only one. So maybe this one is, this number must be deleted. So from the name to the formula, from the formula to the name, they must match. That's so important. And here a question asking you to identify the functional groups or to evaluate the options if they are exist in the given compound. Let's check the aldehyde. So remember the pattern of aldehyde, the R, carbonyl, and then hydrogen. Look at the molecule if there is an aldehyde group. And as you see here, there is no similar pattern. So there is no aldehyde group. But we have a carbonyl compound here, which is not an aldehyde. What about alkene? Is there any carbon-carbon double bond? Yes, there is a carbon-carbon double bond here. This is alkene. What about aromatic group? Maybe this is the easiest one. Look at here, my friends. This is the benzene ring. This is aromatic group. And this is a phenolic group also here. Look at here. This is a phenol because there was a hydroxyl group. And also there was another group here attached to phenol group. What about the ketone group? The pattern of ketone is, remember, the R, attached to carbonyl group, and there is a second R. Is there any pattern in the given molecule? No, there is not. What about the ether? Remember R and oxygen attached to second R, and here we have an ether group. And also another group here, but no option is given for that group. This is an amide. Look at here. This is an amide group. It is R, carbonyl, and nitrogen, hydrogen, and there is a second R here. So this is the R, this is the second R. This is an amide, but no option for the amide. Yes, the given formula, my friends, is the capsaicin. So this is an active molecule in peppers. In peppers, which creates the hot taste, and it is highly powerful antioxidant, which there are too many studies about capsaicin. You can check indexes. So write the capsaicin as a keyword to the PubMed. I suggest you. Sorry, PubMed. This is a scientific index. Also, you can check from the Google Scholar, but I strongly suggest you to use the PubMed, and you will find too many studies about the capsaicin. And the question 17. Generally, naturally occurring unsaturated fatty acids have a cis configuration. And as you see, the cis configuration here creates a folding in the molecule, which cannot be said in the light of the above information. It is quite common in both animal and vegetable oils. Actually, they are common in vegetable oil. So this is the option. The cis bonds form kinks, bands, or foldings in the hydrocarbon chain. This is true, as you see here also. Fats rich in cis bonds are liquid at room temperature. This is also a true option because the trans ones are not liquid. The melting point decreases as the number of cis double bonds increases. This is also true because at each cis point there is another kink, for example, here, and another cis, another kink. And these bendings pack molecule in order to occupy lesser space, which will decrease its melting point. And that kind of fatty acids, we shortly say EUFAs, and the ones carrying more than one double bond, we call them PUFA, polyunsaturated fatty acids, are highly important fatty acids, and they are essential fatty acids, EFA. And we need them. We need them. Let's continue the last question. Write the UPAC systematic name of the given molecule. Yes. And as this is very easy. There are 4 carbon, which make this but. And what is the suffix? There is a triple, this means butyne. Fine. And there is no any substituent, but we forget something to locate the triple bond. It is at the first carbon. So the name is 1-butyne. That's enough. That's the name, my friends. Because there is no any other substituent or no any other functional groups. Yes, this is the end. And I hope it will be, I help you. It will be helpful for you. And if you have any other question about the topic, do not hesitate to contact me. You can always visit my office. You can always send to me email, and also please Don't forget to subscribe to the YouTube channel Biokimia Wet and also my Instagram account. And you can also send me questions from the Instagram account Biokimia Wet. And see you. Take care of yourself.